Hello guys, welcome back to your channel of learning mathematics. Let us continue with chapter 13, exercise 13.4. So if you remember last class, we learned about a cone. If you remember, I had drawn a cone for you where this was called as the slant height. We had this circular base, right? There we learned how to find out the surface area of a cone, and that a cone has two surfaces. That's the curved surface area, and one is the flat surface, circular base. Today, we are going to learn about a smiley. Yes, a sphere, a ball. And when this sphere is cut in the middle to get exactly two halves, we get a hemisphere, half of a sphere, half of a sphere like this. Okay, but spheres also, of course, there are two types. Spheres also, of course, they are of two types. Like this is a solid sphere because this is just made up of foam. Inside also we have this foam. We also have empty spheres like hollow spheres like football, volleyball, basketballs and all, where the inside is filled up with air. All right, and this is a solid sphere. Similarly with a hemisphere also, you have this soup bowl where this surface does not exist. All right, and this is a solid sphere because the surface does exist here. There is a surface, it's closed. All right, so now of course in short we can say that a sphere is like more like a three-dimensional figure of a circle, something like that. Okay, three-dimensional figure of a circle. Some examples, as I say, are balls. Many consider plates. Plates are plates. Rings are, these are circles. Okay, these are not spheres. All right, so now if I just try to draw a sphere on the paper, I cannot do that, so it has to be a two-dimensional figure only, something like this. So the center of the sphere is also called as a center, of course, and we have the diameter of the sphere. That means this part is radius, this part is also radius, and combined is the diameter, that is double of the radius. All right, same thing happens with sphere also. See, this will be the middle, this will be the diameter, radius, and the remaining half again will be the radius. Combined from here to here, that will be the diameter. All right, then when you look at the surface area, since we'll be discussing about surface area only, a sphere will have only one surface. You can see that we have only this surface, that's only the curved surface area only. Okay, so total surface area is only this one, curved surface area is only this one. So in a sphere there is only one surface. So sometimes it may be called as total surface area of sphere. Sometimes it may be called as curved surface area of sphere, or in general for a sphere we simply call it as surface area of a sphere, and that is given by 4 pi r square. All right, I'm going to get straight to the formulas only so that we can just begin with the exercises and all. Is that clear? So don't be confused when the question says total surface area or curved surface area, especially for a sphere. Remember, we have only one surface in a sphere. Whereas, when you talk of a hemisphere, it depends. Okay, because a hemisphere, when we talk of a hemisphere will have like two surfaces. One is the curved surface area, this curved part, this one, this curved part. And if it is a solid cylinder like this, then it will also have a circular base. Circular base. All right. Now the curved surface area of a hemisphere is given by 2 pi r square, that is half of a sphere. And curved surface, area of circular base is a circle, so that's going to be pi r square. So in a sphere we will have two surfaces. That's one is, as I mentioned, curved surface area, the curved part, and the other one will be total surface area in a sphere, in a solid sphere. Okay, if it's an empty sphere, like if I just take this off like a soup bowl, then this part will not be there. Okay, this part will not be there. So in that case, for a bowl, soup bowl, we will have only the curved surface area only. We will not have this because this part will be open for us. But if you talk of a solid sphere, then we will have this part also, that's a circular part also. So for a solid sphere we will have two surfaces. One is a curved surface area, the other one will be the circular part. So in that case, for a solid sphere, or if it is closed, then it will be total surface area, and that will be given by the curved surface area plus area of the circular base. So that formula will be given by 3 pi r square. Simple as that. All right, so do read the questions properly especially when you talk of a hemisphere, because sometimes they will just tell you we have a soup bowl where there is soup. Right, soup, of course, in a soup bowl we'll have soup also. Then they will just cleverly tell you find out the total surface area of the soup bowl. So even if they say total surface area of the soup bowl, be clever. If they are clever, you should also be more clever. All right, if they try to fool you, you also try to fool them. Okay, so they will tell you find out the total surface area of the hemisphere. Then in that case, even if it's total surface area, we know that this open part, this will be open. So total surface area for a soup bowl will also be same as curved surface area only, because this part will not be there. All right, but if it is closed or if it's a solid, then in that case, yes, we will cleverly understand that okay, this upper part also will be there. All right, so once again, curved surface area, total surface area for a sphere, it's the same, because in a sphere we have only one surface, that's a circular part. All right, so surface area of a sphere is 4 pi r square. Whereas for a hemisphere, it depends on the question. Like if you have a bowl where the upper part is not there, then you'll have only the curved surface area. But if it's a solid hemisphere, then in that case we will have the total surface area, that is one more circular base, 3 pi r square. All right, fine then. Okay, so let us just continue with the exercise. So as the exercise goes, it's something like this. The first question is find the surface area of the sphere. Find the surface area of the sphere of radius number 1, 10.5 centimeters square. So let's find out sphere. Okay, so surface, in short only, surface area of sphere will be 10 centimeter. So that's 4 pi r square. That is 4 into, I'll use 22 by 7 in the question that is given. 22 by 7 into 10.5 whole square. So that's going to be 4 into 22 by 7 into 10.5 into 10.5. So that's going to be 7 ones are 7, 7 ones are 7, 8, 9, 10, 15. So that's going to be 4 into 22, 88 into 1.5 into 10.5. So that I'm going to calculate directly. That's 88 into 1.5 into 10.5. That's going to be 1386 centimeters square. Fine. Number 2, I'm going to do it directly. Since radius is already given here, I'm just going to go straight for the surface area just to save some time for all of us. That is again surface area of a sphere for the second one would be again same formula, 4 pi r square. That is like 4 into 22 by 7 into 5.6 centimeter whole square. So that's like again 4 by 22 by 7 into 5.6 into 5.6. 7 ones are 7, 0.8, because 7 8s are 56, so 5.6 means 0.8. So that's again going to be 88 into 0.8 into 5.6. So that also let's calculate. That will be 88 into 0.8 into 5.6. So that's going to be 394.24 centimeter square. Done. Third one, again directly surface area of sphere, 4 pi r square. So that's going to be 4 into 22 by 7 into radius 14 centimeter whole square. So that's 4 into 22 by 7 into 14 into 14. So 7 centimeter square, of course. So that's like 88 into 28. So how much will be 88 into 28? 88 into 28. So that's going to be 2464 centimeters square. Done. You can note it down. All right, let's move on to the second one. That is find the surface area of a sphere of diameter given this time. So diameter is given to be 14 centimeter. So we'll first need to find out the radius. That's going to be 14 by 2 centimeter, that is 7 centimeter. So that will be, therefore, surface area of sphere will be again same 4 pi r square. That's going to be again 4 by 20 into 22 by 7 into 7 centimeter square. So that's 4 into 22 by 7 into 7 into 7, 1717 cancel. So 88 into 7, so 7 8s are 56, 5 left, 7 8s are 56, 61, 616 centimeter square, 616 centimeter square. Second one, I'll do it directly. That is here again, diameter again is 21 centimeters. So what will be the radius? 21 by 2 centimeter. So surface area of sphere 4 pi r square. So that's like 4, 22 by 7, 21 by 2 centimeter whole square. So that's like 4 into 22 by 7 into 21 by 2 into 21 by 2 centimeter square. 7 ones are 7, 7 3s are 21, 2 ones are 2, 2 2s are 4, again 2 ones are 2, 2 2s, 2 ones are 2. So that's like 22 into 3 ones are 3, 3 2s are 6. So how much will that be? 22 into 63, that will be 1386 centimeter square. Done. Alright, so third one I'm going to do in the rough, that is 3.5 centimeter is the diameter. So I'm going to do it here. Rough paper, saving paper. So diameter is given us, the third one, that is 3.5 meters. So radius r will be 3.5 divided by 2. This time it is meter, no problem. So surface area of sphere will be 4 pi r square. So that's like 4 by 22 by into 22 by 7 into 3.5 by 2 meter square. So 4 into 22 by 7 into 3.5 by 2 into 3.5 by 2 meter square. 2 ones are 2, 2 2s are 4, 2 ones are 2, 2 2 ones are 2. So 7 ones are 7, this is 0.5. So 22 into 3.5 into 0.5 meters square. So how much will that be? 22 into 3.5 into 0.5. So that is 38.5 meters square. 38.5 meters square. Done. You can note it down. Oh yeah. Okay. All right then, so let's move on to the second, number 3, question number 3. What is the question? Find the total surface area. See, remember, total surface area of a hemisphere. Total surface area of a hemisphere. Remember, so they haven't given us any clue whether it's a bowl, this is empty, this and that, nothing is given. So it means total surface area, since they haven't given us anything, like whether it's a soup bowl, whether the surface exists or not. So in this case, what we will assume is, yes, we will assume that total surface area represents to that hemisphere whose circular part is also there. Okay, that means curved part plus circular base. Okay, in that case we will have to assume like that. Radius is given. (10 centimeters). So fine, total surface area of hemisphere. So hemisphere. So what was the total surface area of hemisphere? Square surface area, that is half of sphere plus one more circle, that is 3. So 3 pi r square. So that's going to be 3 into, they have told us to use the value of pi as 3.14. We'll have to obey. 10 centimeter whole square. So 3 4s are 12, 1 left, 3 1s are 3 plus 1 4, 3 3s are 9. 9.42 into 10 square is 100 centimeters square. So 942, zeros, so 2 decimals, centimeters square. So that's going to be 942 centimeter square. Simple question. Done? Chalo. Next question is, the radius of a spherical balloon increases from 7 to 14 centimeter as air is being pumped into it. So initially our balloon was something like this, whose radius was 7 centimeter. Then we pumped air into it again, so the balloon of course gets bigger with a bigger radius, that is 14 centimeter. Now the question is, find the ratio of the surface areas of the balloon in the two cases. So only the surface areas only, so that's not going to be a big problem. So it's going to be surface area of the balloon, big balloon, surface area of the small balloon, we will have to find out and then get its ratio. All right, so let us say radius of balloon in first case, let us denote it by small r, 7 centimeter. Then radius of balloon in second case, capital R, bigger balloon, na? 14 centimeter. So shall we go for the ratio directly? Chalo. So ratio will be equal to ratio of the surface areas of the balloon in the two cases. So that will be surface area, since this is bigger, we'll write that surface area of big balloon bigger upon surface area of smaller balloon. Right? Find the ratio of the surface areas of the balloon in the two cases. So balloon, complete balloon, that's a sphere, so that's going to be 4 pi, sorry, find the ratio of the surface area of the balloon in the two cases. So sorry, smaller balloon is given first, isn't it? And then only the bigger balloon. So sorry, very sorry, I got, this will be smaller balloon and bigger balloon, because the smaller balloon first, isn't it, increases from 7 to 14 centimeter. Find the ratio of the surface areas of the balloon in the two cases. So from the smaller to the bigger, isn't it? So it has to be smaller upon bigger. So that's going to be 4 pi r square divided by 4 pi capital R square. 4 pi cancels. So what is r? 7 centimeter whole square. The other one, 14 centimeter whole square. I'll just do it here. 7 into 7 centimeter square. 14 into 14 centimeter square. Square cancel. 7 ones are 7. 7 twos are 14. 7 ones are 7. 7 twos are 14. 1 upon 4. So the ratio is 1:4. 1:4. Clear? I'm very sorry for this one. Okay, it should be smaller to bigger. No, sorry. Alright, so that will be the ratio. The ratio will be 1:4. Done? Ho gaya? Chaliye. Then moving on to number 5. You can pause the video also. No? Okay, 5 is a hemispherical bowel. You see, bowel. Made of brass, has inner diameter, let's say something like this. So the inner diameter is given to be 10.5 centimeter full. 10.5 the diameter. Find the cost of tin plating it on the inside of the inside of the bowel at the rate of rupees 16 for every 100 centimeters square. So they haven't mixed up the question, because they have given us a diameter of the inner bowl only, and then they are also telling us to find out the cost of tin plating it on the inside only, not outside. So no problem with that, only the inside only. So only the inside tin plating, and remember this is a bowl, so this part is open, a soup bowl. So that means we will just find out the curved surface area, because this is the area that I will need to tin plate it, isn't it? So I'll just find out the curved surface area, find out how many centimeter square centimeter square area is there, multiplied by rupees 16 for every 100 centimeter square. From there we'll have the cost. Inner diameter, they have just confused. Don't be confused with this inner diameter, okay? Thickness, outside, they didn't give us a thickness, and then they haven't told us to tin plate outside, nothing. A simple question, inner diameter is given, find the cost of tin plating it on the inside. So there's nothing involved there. Radius will be 10.5 by 2 centimeter. So let's find out the curved surface area of hemispherical bowl. Bowl means this upper part is not there, so only the curved surface area only. So that's going to be 2 pi r square. 2 into 22 by 7 into r is 10.5 by 2 centimeter square. So 2 into 22 by 7 into 10.5 by 2 into 10.5 by 2 centimeter square. 2 ones are 2, 2 11s, 2 ones. 7 1, 7 ones are 7, 8 9 10, 3 left 15. So it's 11 into 1.5 into 10.5 centimeter square. If you wish, we can calculate, no problem. 11 into 1.5 into 10.5. So the total area that we have is 173.25 centimeter square. Now in the question it is given that rate of tin plating is rupees 16 per 100 centimeter square. So that means for 100 centimeter square the cost is how much? Rupees 16. That means for 1 centimeter square the cost will be rupees 16 by 100. Therefore total cost for 173.25 centimeter square will be rupees 16 by 100 into 173.25, because for 100 centimeter square cost is rupees 16. That means for 1 centimeter square cost will be 16 divided by 100, bring cost multiply. So for 1 centimeter square cost is rupees 16 by 100. So for 173.25 centimeter square cost will be rupees 16 by 100 into 173.25. Wow, that's going to be rupees. Let's multiply this one. If you multiply into 16, we will have 2772 divided by 100. Let me just multiply that for you, okay? For this question, let me just multiply. There is 173.25 divided by into 16. 6 5 30, 3 left 12, 15, 1 left 19, 1 left 6, 42, 43, 4 left 6 6 10 into 5 2 3 7 1. So 0 0 10, 1 left 9 10 12, 1 left 3 6 7 7 2. So that's 2772. I'll just write here it's 0.00, doesn't matter of course. So that's going to be rupees 2772 by 100. So that will be rupees 27.72. Rupees 27.72. So that will be the cost of tin plating the soup bowl, inner portion. Alright, so alright then, that's it. We'll stop there for today. The remaining questions, that is up to question number 6, 7 and 8, we will do it in the next video. Alright then, till then, study well, take care. I'll see you in the next video. Bye bye.